All right, today we're going to talk about Pascal's triangle. You're going to see if you, I want to see if you can figure out how we generate this triangle. So we have a 1, we have a 1, 1, we have a 1, 2, 1, a 1, 3, 3, 1. How am I going to get the next row? What will the numbers be? Can you think about it and figure it out yet? I'm going to write them, see if you figure out how I did it. How did I get these numbers using these numbers? Most of you should have it by now. So the next row is going to be 1. 4 plus 1 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1. Now, this is what we call a recursive relationship, in that it ascends, getting bigger, and then it descends, getting smaller in the same pattern. So our next one is going to be 1. 5 plus 1 is 6. 5 plus 10 is 15. And 10 plus 10 is 20. And 10 plus 5 is 15. And 5 plus 1 is 6. And then 1 on the end. All right. So actually there's zeros down these sides, by the way. And that's how you get 0 plus 1 being 1. And these zeros go out forever, extend forever in every direction. So it really follows that pattern all the way through. Now, what we're going to do is, what do we use this for? I mean, it's kind of cool and everything that you can just add two numbers and get the next. But what is it used for? Well, let's take a look at what it is used for. Let's expand x plus y, the binomial, raised to the 0 power. Well, what's anything raised to the 0 power? You can punch anything into your calculator, raise it to the 0 power. What's it going to give you? It's going to give you 1. Okay? So anything to the 0 power is 1. Say, okay. All right, how about x plus y to the first? What will that give you? Well, that's going to be 1x plus 1y. Okay, that makes sense. How about x plus y to the second? Well, if you remember, we square this out. We take the first term squared. First term times second term doubled. Last term squared. Starting to see a pattern? Let's do x plus y to the third. I'm going to expand this a little bit. I'm going to do it as x plus y times x plus y squared. Isn't that true? X plus y cubed is x plus y times x plus y times x plus y. But I wrote it this way because I know what x plus y squared is. I just did that. I have x plus y times x squared plus 2xy plus y squared. Now I distribute, and that gives me x cubed plus 2x squared y plus xy squared. Now I'm going to distribute the y, and I end up with x squared y 2xy squared y cubed. Add my like terms. X cubed plus 3x squared y plus 3xy squared plus y cubed. Notice the coefficients of 1, 3, 3, 1. Now, that took a little bit of work there to multiply that through, add like terms and everything. I could do that again using this value to find x plus y to the fourth, but I could just use this expansion with these. Notice here the x is descending, going from 3, 2, 1, none. Sorry, none. And the y is ascending, going from none to 1 to 2 to 3. So the x is descending, the y is ascending. The binomial theorem, which comes from Pascal's triangle, is leading the way. So there's a little song, if you want, that just says, the x is descending, the y is ascending, the binomial theorem is leading the way. That's an easy way to remember how this works. So if I want to expand this, I really don't have to do all this multiplication. I can simply use these coefficients and then just have the x descend and the y ascend. So the first term is going to be x to the fourth. That's the same power that we start with on the x. Now, if there was a number in front of the x, we'd have to raise it to the fourth, and I'll do one of those in a second here. Okay, so we're going to have x to the fourth plus 4, that's coming out of Pascal's triangle, x cubed y. These total 4, if you'll notice. 4 plus 0 for the y would be 4. 3 plus 1 is 4. So these are always going to total 4. Just like these all totaled 3. 3, 2 plus 1 is 3, 1 plus 2 is 3, and 3. These are going to total 4. Plus 6. The x is descending, x squared. The y is ascending, y squared. 6 came from there. Plus 4x, x is descending, and the 4 came from there. The y is ascending, so it's going to be y cubed plus y to the fourth. Okay. So expanding these is kind of key, using these coefficients and then timesing it through with these squared values. Now, here comes the tricky part. You can keep doing this, by the way. You could go all the way down to 7, so forth, just by adding the previous two terms. And you can expand these easy. Here's where it gets a little complicated. So let's do a fairly simple one on the next one. Let's do x plus 1, and let's do this one to the 5th, just for fun. What would this end up expanding to be? Well, now notice that the y isn't a y, it's a 1. So all these y's will be 1s, and 1 to any power is pretty easy to do, so this is going to be fairly easy. I'm going to follow this row of Pascal's triangle. How do I know what row to follow? Well, it's always the exponential value on the binomial. So if we have a binomial to the 5th, we're going to follow the row with the 5s. And we're going to end up with x to the 5th plus, remember, the x is descending, the y is ascending, the binomial theorem is leading the way. I'm going to go plus 5 times x to the 4th, 1 to the 1st, if you will. Okay, the 1 is coming from the y. Then I'm going to go plus 10, again, x is descending, x cubed, y is to the 2nd, but y is 1, so it's 1 to the 2nd. Put that in parentheses, I guess. And then plus 10x squared, 1 to the 3rd, plus 5x, 1 to the 4th, plus 1 to the 5th. Now I just times that out and add and put them together. So I have, there won't be any like terms, by the way. X to the 5th plus 5x to the 4th. All these 1s are just going to times through. Plus 10x cubed plus 10x squared plus 5x, because 1 to the 4th is 1 times 5, plus 1, because 1 to the 5th is 1. And that's it. So that's pretty easy. But what happens if we had something, say, like 2x plus 3y, and we raised it to the 4th power? Okay. Well, now you've got to take these coefficients, the 2 and the 3, and raise them to the powers along with the powers of the the power of the exponent raised to both the coefficient and timesing by these coefficients that come from the binomial theorem or Pascal's triangle. Okay, so that's what we're going to do. So here we have, again, 2x raised to the 4th. Now really there's a 1 in front of that, coming from this row right here. So there's a 1 in front of that. Now I'm going to go plus, and now I have to put this coefficient, the 4. Then I'm going to take 2x raised to the 3rd power and a 3y raised to the 1st power. Then I'm going to go plus 6, again that came from Pascal's triangle, 2x raised to the 2nd power, again descending, first term descending, 3y raised to the 2nd power, y values ascending, or the 2nd term ascending, plus 4, that came from here, 2x, that's to the 1st power, because notice it went from 4, 3, 2, now 1, and then the 2nd term's value, 3y, is going to be raised to the 3rd power. And then finally, no x value, 1 is the coefficient, and we're going to have the 3y raised to the 4th power. Okay. Now all you got to do is multiply all this out, but that is a pain to multiply all this out. When you do 2 to the 4th, I'm going to have a lot of kids write 8. That isn't 2 to the 4th. Remember, it's 2 times 2 times 2 times 2. In other words, that's going to be 16, because 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16. So 2 to the 4th is 16. You can do that on your calculator also if you need to. So 16x to the 4th plus, now I got to times all this out. 2 to the 3rd is 8, 3 to the 1st is 3, and I have to times it by a 4. So 4 times 8 times 3. Well, 4 times 8 is 32, times 3 is 96. So I'm going to have 96 x cubed y to the 1st. Okay, now I'm going to have my next one, plus 2 squared is 4, 3 squared is 9, times 6. So 4 times 9 is 36, times 6. So this is 216. X squared, y squared. Then I have 2 to the 1st, which is 2. 3 cubed, 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, times 4. So that's going to be 8 times 27, which is 216. X squared, y, x to the 1st, y to the 3rd. Sorry. Then I'm going to have plus 3 to the 4th, that's going to be 3 times 3 times 3 times 3, or 9 times 9, which is 81, y to the 4th. And that's the expansion of 2x plus 3y to the 4th power. So sometimes you'll have to multiply those out, use your powers. So 2 cubed gave me the 8, 3 to the 1st gave me the 3, times all those out and you'll get it. Okay? That's basically how you use Pascal's triangle to expand the binomials. And that's what you'll be doing on your assignment today. There's just one last thing I'm going to show you. This is just playing around with golf balls when you're on quarantine. So I'll show you this. So think about what I have right there. I just made a little stack of golf balls. How many golf balls are on the top level and how many are on the second level? Okay, think about that. Now we have another stack of golf balls. How many are on the bottom level? And how many are on the second level? And how many are on the top level? And then how many total are there? Think about that. So again, how many are on the bottom level? How many are on the middle level? How many are on the top level? That's easy. And then how many total golf balls are there in this configuration and that configuration? What would happen if I made another stack? Okay, I want you to think about that compared to Pascal's triangle. We'll actually do some of this when I get back on Thursday. But I want you to think about that configuration that we have. One last thing I want you to think about, and again, this will just be stuff we do next time that deals with Pascal's triangle. But think about this. Think about having 4 letters, A, B, C, and D, and arranging them any way you want, 4 at a time, 3 at a time, 2 at a time, 1 at a time, and 0 at a time. How many ways could you arrange those 4 letters 4 at a time? Well, so not necessarily arrange, group them 4 at a time. So all we would have is one grouping of A, B, C, and D. The order doesn't matter. That's what I'm trying to say there. So the order won't matter, but they have to have different, obviously then, different values. How many could I arrange them 3 at a time? Well, I could have A, B, C, A, B, D, and then A, C, D, and that's all the ways I can use A in it. But I still have one without an A, which is B, C, D. Notice there's 4 ways to do this. There's 1 way to do that. Think through these other ones. Okay? And again, we'll do that when I get back on Thursday. Okay, I want you to do the assignment on Pascal's triangle that should be handed out.